Welcome everyone here to my senior thesis presentation on the effects of the Martin sodium bicarbonate system on 5K running performance. I'll be referring to the Martin sodium bicarbonate system as the Martin system throughout this, just it's a little bit easier to say. And sodium bicarbonate is also commonly known as baking soda, just so everybody knows. My name is Q, and I was mentored by Dr. Jobert, who sadly can't be here. He can't attend today because he teaches at another university now, but I also was mentored by the lovely Dr. Ballard. And she thankfully took over after Dr. Jobert couldn't be here anymore, and I'm thankful for both of them for guiding me for this past year, and I really couldn't ask for better mentors. My main points today that I would like to cover are first the background that needs to be understood to grasp how this study works, and secondly, I'm going to go over similar bicarb studies that led me to my purpose statement, and finally I'll go over the Martin study that I performed this summer, where I'll explain my methodology, results, and conclusion. First, I would like to start with a disclaimer that is a common mistake found in biology classes. Lactic acid is said to be the reason for muscle fatigue, and that's simply not true. If anyone takes an exercise physiology class, that you'll learn that muscle fatigue is actually brought on by the buildup of hydrogen ions. And this is called acidosis, meaning that it's an acidic environment in the blood and muscles when you do high-intensity exercise. And in a biology textbook, you would learn that in the absence of oxygen is when lactic acid is produced, but it's actually produced all the time, even during times of rest. Since lactic acid is a weak acid, it dissociates or separates slowly into a hydrogen ion and a lactate molecule, which is actually shipped off to the liver and recycled through the Cori cycle to make more energy for the body. So it's not a dead-end product that causes these symptoms of muscle fatigue, it's actually the hydrogen ion buildup. Moving on to more background information, let's start with what a buffer is. A buffer is a weak acid-base pair that consists of a weak acid and its conjugate base pair, or a weak base and its conjugate acid pair. A buffer contains this pair in an equilibrium so if an acid that's full of hydrogen ions is added to the system, the conjugate base neutralizes it, and if a strong base is added, the weak acid would neutralize it. This equilibrium is why the buffer solution can resist changes in pH that are commonly seen in the presence of high-intensity exercise. Buffer systems that are naturally found in the body, and they maintain that pH homeostasis in the blood and the muscles that are using that equilibrium. There are many natural buffer systems that can be found all throughout the body, but the main one that I want to focus on is the bicarbonate buffer system, which is aided by the respiratory system. So as we all know, when you exercise, you start to build up that muscle fatigue with that extra hydrogen ions. We start to breathe harder, we start to hyperventilate. This is because when the blood becomes too acidic, the brain tells the body to start breathing harder, since the excess hydrogen ions are grabbed by this bicarbonate molecule and turn into carbonic acid, which breaks down into carbon dioxide and water, and then carbon dioxide is exhaled by the lungs. This would help bring the pH back down to its normal range of 7.3 to 7.45, which perfectly coincides with the target pH of 7.4 that the bicarbonate buffer system is known for staying at. So, if the body's pH drops below 7.3, it would be considered acidosis, and if the pH is above 7.45, it's considered alkalosis. For the Martin system, it comes in this cute little box, and it has three parts. First is the bowl, and it has a marking where the water should go. And next is the bicarbonate pellets that are found, and you measure those out according to somebody's body weight. Then there's the carbohydrate hydrogel that's also mixed into the water, and it's all mixed together in this bowl. Made sure to mix it really properly to ingest it, I guess. But Martin also has these claims of this supplementation. So the first claim is that it does not have any gastrointestinal or GI symptoms that are normally found with the ingestion of sodium bicarbonate solutions. This is because in former studies, before the hydrogel ingestion method, runners used to ingest baking soda dissolved in water, which causes a lot of major issues, such as nausea and stomach bloating. The second claim is that it would increase the performance, since it would increase in the amount of bicarbonate that's in the blood, creating that alkalosis, but with the acidosis coming from the exercise, it should be able to even it out with that equilibrium again. This means that the muscle fatigue that would be delayed since the excess hydrogen ions would be picked up by the excess bicarbonate in the blood, it would be keeping it within that normal range of pH. And the last claim is that it has this increased buffering capacity. The usual buffering capacity is actually just a couple minutes with just the baking soda and water. But with the ingestion method, supposedly it can last for hours, meaning that endurance or marathon runners should be able to benefit from this kind of supplementation. So moving away from all the chemistry stuff, because nobody wants to hear about that, and I want to move on to similar bicarb studies that have already been done that led me to my purpose statement, and then I'll touch on a couple of endurance performance studies and some similar performance studies such as cycling and sprinting that also helped me give a little bit of perspective of how I came up with my study. For similar studies, endurance performance studies on sodium bicarbonate, there's actually just a very few done and none of them show any significant differences in running times. Such as these two, these were found in a meta-analysis with over 120 studies done on sodium bicarbonate, and only 2 were long-distance running studies. And they got the same result, even though they were 21 years apart. Now for the cycling and short duration, even though endurance performance says there's no improvement in performance, that doesn't mean that all bicarb studies have never shown any improvement in performance. First, there are cycling studies that are still considered long distance, but the problem is that the majority of these studies showed improvement, but it's hard to compare endurance running to cycling since it's a different type of performance. There's a sprint type of performance within cycling that's just hard to compare the two. And next is the short endurance running, or sprinting. There were about 5 out of 7 studies in the meta-analysis that showed this improvement for time to fatigue, which is actually really hard to quantify since it really depends on the mentality and motivation of these participants, which I later took into account in my study. Since bicarb solutions were actually known for that low buffering capacity of only a couple minutes, it was popularly used as an ergogenic effect for this short duration, high intensity exercise performance, such as sprinting. And this led me to my purpose statement. Using this information, it really got me thinking about how Martin claimed these increase in buffering capacity time from minutes to hours. So the purpose of this study is to see if the Martin bicarbonate system can improve a longer distance, or a 5K performance, which is actually about 3 miles. So finally, I would like to talk about the research I conducted this summer with Dr. Joe Baer. I will not now go into detail about my methodology chosen for my study and the results I collected and the conclusions I made from those results. For my methods, we had 8 male subjects that had to qualify by running at least 3 runs per week for 3 months and had to have a sub 21-minute 5K. This is so we are testing athletes that were considered elite, because these are the most likely group to actually use this type of supplementation. Our study design was a repeated measured crossover randomized single-blind study, which basically means that there was 2 trials and the participants didn't know whether they were taking the supplementation or the placebo, but we did. For our procedures, we gave very specific pre-visit instructions, some surveys, and we had a certain dosing of supplementation, and of course our 5K time trials. For our pre-visit instructions, we had them do what was called a SAP and SIN, which was basically just a control to make sure that they were having the same eating habits between both trials. We also asked them not to consume any caffeine or alcohol 24 hours before, since studies on possible ergogenic effects from caffeine have been looked at before, and alcohol can affect somebody's motivation or participation in some studies. We just wanted to make sure to not do that and impact our possible limitations on our study. So we made sure to just cut all of that out. We also asked the participants not to come in fasted, so we had to make sure that they had eaten before they took their supplementation, since that's what the Martin guidelines had told us to do. And for the supplementation, we had a specific dose of bicarb measured out based on each participant's individual weight. Then we followed up with the timing that the Martin system recommended, which is about 2 hours before the race. And for our placebo, we just used the carbohydrate hydrogel from the Martin system with some sprinkles that kind of looked like the bicarbonate pellets. For our 5K time trial, we had a standardized warm-up, but we also gave them about 10 minutes to warm up as they usually would, since we wanted to keep the race as realistic as possible as what they would use it for. And the trials were held here on our lovely campus, and we had about a 1 mile loop, and so that means they made 3 loops around this campus. For our surveys, we did a couple different ones just for controls, and first was the readiness score, where we just made sure that they were coming in each week with the same mentality. And the second one was a visual analog scale, or a VAS, for tracking those GI symptoms that might arise with sodium bicarbonate supplementation. Okay, now for some results. For this graph, we're looking at 2 time trials that participants did where we compared their placebo time to their bicarb time. Each of the light blue lines represents an individual's pair of time trials, and the dark blue line is just the average of all those times. All of those lines actually go down except for one, and that one goes up 0.04 minutes or 2.4 seconds slower, but the average benefit was actually 0.29 minutes or 17.4 seconds faster, which in endurance runners, that's a very big difference. For my next graph, we have lap times averaged between the placebo and the bicarb for all of the subjects, where each lap is about 1 mile. The light blue line is the placebo average, and the dark blue line is the bicarb average. In the beginning, you can see that the lap 1 time, both the placebo and the bicarb have about the same time, which is actually normal for distance runners since they usually try to understand their pacing on their first lap. Then in lap 2, both the bicarb and placebo get better by going down in time, but the bicarb seemed just a little bit better than the placebo. Then finally in lap 3, the placebo gets worse by going up in time, which might be an indication of muscle fatigue that we're looking for. Then the bicarb just continues to go down, which might be because the participants didn't have that muscle fatigue affecting them. Next is the readiness scores, which we took each morning of the trial just to make sure those participants were coming in each week with about the same mentality. This top graph is actually filled in depending on how they felt when they came in. And as you can see, these results were very negligible between both the bicarb and placebo, seeing as they're almost the same for both conditions every single time. Now for the VAS. We scaled this from 0 to 10, 10 being the most severe symptoms, which you can see in the top left corner. As you can see, the results for the overall gut discomfort for both conditions and all 4 time points are less than 1, meaning there were no symptoms to the low side of mild symptoms. This was very much considered negligible. Finally, here are my conclusions I made from these results. Since the VAS showed negligible results, the Martin hydrogel ingestion method was considered effective. And my next conclusion was that the Martin system can improve 5K running performance since there was a significant average benefit of about 17 seconds in total time. For some possible future studies that would be interesting to see would be see if there's similar benefits for women. We only got to test on men. There are not many studies done on women in general, and since women have different pH than men, it would be helpful to see if this could help women as well as men. There's actually 45% of marathon runners are women, and 50% of all runners are women, so it would greatly help women in a way to see if this could help them too. Another testing that Martin could do, so maybe some longer distances, since it can buffer for hours, maybe to see how long this buffering capacity could go for. So maybe a marathon, a half marathon, who knows? It could be interesting to look into. But thank you. Does anybody have any questions?
I had a bit of a two-part question. So I understand that your methods, I guess for the way of measuring it, included a survey that the athletes themselves did. Do you know if the 2 ones that you mentioned or you referenced in the beginning were also like survey-based responses?
Like the VAS and the readiness scores?
Yes.
Yes, they were both filled out by them. So the VAS was filled out 4 times over the entire trial. It was right before we gave them the supplementation, 1 hour after we gave them the supplementation, 2 hours after they gave the supplementation, so right before they raced, and then they raced, and there was another time right after they got done with their race, they filled it out again.
Okay.
So, and then the readiness score was done in the morning.
Okay. So then for the ones that you referenced before, it was like 1996 and then 2000.
So those studies were done into a meta-analysis. So they didn't specifically quantify any of that. They just kind of like, oh, run this 40-kilometer thing and
Okay, gotcha.
to see if it would do anything.
And so then for my second question, sorry, to anybody. Do you know if there's any way to actually test like the chemical, like H ions of the runners and athletes?
So that's interesting that you bring this up because we were going to take lactate measures and it proved to be a little complicated and a little bit too much for what we were trying to do, so we actually didn't get to. I would have to guess there would be a way in some kind of chemistry lab to test like blood to see if you can put like strong bases. If you ever take a chemistry class here, they do test buffer systems and they add very strong acids to a buffer system to see how it works, and you can watch the pH go down and then come back to where it was supposed to be. So I'm guessing you probably could with blood. I mean, I wouldn't know how to do that because it's a little bit more complicated than what I've done. Anybody else?
This was all really, really fascinating. I was taking pictures for my husband who's a runner. I just have kind of a basic question, which is, what was the placebo? What did you give people so that they wouldn't know what if they were taking this or not?
Okay, so we went out and we tried to find some sprinkles that would look a lot like it. And so we did that, and since it's sprinkles, there's sugar in sprinkles, so we actually had to decrease the carbohydrate hydrogel to even that out, so it would actually be the same amount of sugar that they're still getting. And we kind of added salt, since sodium bicarbonate is actually a salt. It would taste salty, so we had to add salt to it to make sure they didn't know.
That's awesome.
Yes.
Could you go back to that chart? This one right here, I didn't get a chance to look at it, and I thought that was, the readiness scores were really interesting.
I don't know anything about chemistry, but as someone who does enjoy running, I was wondering if there was a control that you had in terms of time of day, temperature outside, like their best times of the day that they enjoy to run, their opportunities to run, since it's humid one day, dry another.
Yes, so we actually did take that into account. They ran exactly 1 week apart. Here on campus, we made sure to take the weather here, and it was actually almost exactly the same every single time they ran.
Oh.
Yeah, so it was like 85% humidity, it was like 85 degrees, it was really, really hot and humid. And so like we also had their best PR times given to us, but we didn't share those with anybody because those are their personal times, I guess. So, but yeah, we tried to control the environment as much as we could. So we had them exactly 1 week apart. We did it at the same time every day, and like so it was pretty controlled.
Could temperature affect the chemistry of like their CO2 levels and the blood that's pumping? I feel like.
So the temperature would be able to vasodilate, so it would get their blood pumping a little bit more, but I don't think it would affect the chemical level of it, maybe just the circulation level of it. Do you have a question?
I was going to say, you mentioned about doing the study on women, but I'm guessing the system that you used was mostly targeted towards men. Is there a specific way that you would be able to like fix the measurements, or would they be like adverse effects in women specifically?
I don't think it would be adverse effects, since it's just kind of like, it should be kind of similar pHs. It's just like, since women have different kinds of bodies, their pH is a little bit different than men. So we would hypothesize most likely that it would help them because it helped men, but we just don't know, since there's just not very many studies done on women, and we tried to get women to get in. It's just the participation was kind of low in the first place when they applied, and then their like timing just didn't work out with us. So we would probably aim it a little bit more towards women, which we tried, but sometimes it's just harder to get women to sign up, since safety measures, women are a lot more cautious of things. They don't really like reach out to do things like that as much, but you never know. We could probably try to gear it a little bit towards women if we wanted to. Anybody else?
Thank you so much. We're joined by Dr. everything that he's contributed and done in the honors program over the past 4 years. So congratulations.
I have had the pleasure of having Q in a couple of different classes over the course of her time here. And I've always found her to be a strong and very smart student. But until I actually worked with her on this, I didn't realize exactly how strong and how smart she really is. I mean, it was very impressive, and I'm very, very proud of her. She represents kinesiology very well. So.